This week's chapter reading is on atmospheric moisture. We're going to step back a moment and first just consider water. Water is important, obviously. Currently, California is just emerging from a drought, so in theory, we all have a heightened awareness about water use and the importance of water conservation. Realistically, though, many people, unfortunately, still use water recklessly and have very little knowledge about how much water they are using. Before we dig into the properties of water, let's first identify why water is so important. First, it is essential for all living organisms. That's pretty obvious. Second, it shapes our landscapes through the processes of weathering, erosion, and deposition. Geographers are very interested in how water shapes our landscape and how humans have impacted these natural processes and what changes in our landscape will result from the human impacts. Third, water helps moderate our climate, both globally as a greenhouse gas and regionally as we compare continental interiors to coastal locations. First, as a greenhouse gas, water vapor traps long-wave radiation, heat, that is emitted from the Earth, and this trapping of heat helps warm the troposphere. Next, consider two cities at the same latitude, perhaps Redwood City at 37 degrees north, and then a similar city at 37 degrees north in the interior, say somewhere in Kansas. Here in Redwood City, we're quite coastal, and we experience much more mild winter temperatures and much more mild summer temperatures than they would in the interior of the continent in Kansas. All right, one last thing. We've noted that water is essential for all living organisms, but what do humans use water for exactly? Well, there's many uses, of course. Drinking, cooking, washing, agriculture, manufacturing, mining, energy production, and waste disposal, to name a few. Most people would have no problem noting these first four uses, although they would be quite shocked to learn exactly how much water we use for agriculture. These last four uses, though, are a complete mystery to most folks. An enormous amount of water is used for energy production, mining, waste disposal, and yes, for manufacturing all of our consumer goods. Indeed, water exists all around us, in oceans, lakes, rivers, ponds, in the soil pores near the surface, and in the groundwater, in clouds, and simply as moisture in the air, and also, of course, in the bodies of all living things. Yes, we are all quite familiar with water. We sometimes say that water is ubiquitous, which essentially means that it's everywhere. But water is also an incredibly interesting and unique substance. Your textbook notes many important properties of water. We'll list most of them here, and we'll discuss a few of them. Be sure that you can list these important properties and describe the impacts related to physical geography. First, water is present in all three phases. This is just cool. Water is the only naturally occurring substance that is present in all three phases, solid, liquid, and gas, on the surface of the Earth. Also, water expands when it freezes. Most substances contract and get more dense when they change from liquid to solid. However, water expands. Perhaps you found this out the hard way when you put a full bottle of water or soda in the freezer. This is also important for homeowners in cold climates because they worry about pipes freezing and bursting in the winter. Another consequence is that solid ice is less dense than liquid ice, so it floats on the liquid. You've seen this with ice cubes in a glass of water. There are also major geological and ecological implications of the fact that water expands as it freezes. First, when water freezes and expands in cracks of rocks, it can actually break apart the rock. This is a very important mechanical weathering process called frost wedging, which we will study later in the course. Additionally, since ice floats, lakes freeze from the top down and not from the bottom up. If solid ice was more dense than liquid water, lakes would freeze from the bottom up, and living organisms like plants and insects and fish and frogs and other aquatic animals would not be able to overwinter in lakes and rivers. And life as we know it would be very different. Next, a very important property of water is that it is a polar molecule, formed by strong covalent bonds between hydrogen and oxygen. We say that water is polar because even though it has an overall neutral charge, one side of the molecule, the oxygen side, has a slight negative charge, and the other side of the molecule, the hydrogen side, has a slight positive charge. As a result, water molecules tend to arrange themselves in such a way that the positive side of one molecule is next to the negative side of another molecule. Opposites attract. This attraction forms a hydrogen bond. Hydrogen bonds are pretty weak, but they do make it possible for water molecules to stick to one another, which is important for several reasons, as we'll see here. Because the water molecules are polar, they tend to stick together, forming hydrogen bonds, and this sticking together is called cohesion. This causes water molecules to bead together, effectively giving water a very high surface tension. Have you ever noticed you can fill a glass of water a bit above the top of the glass? Strange, eh? This occurs because of cohesion. Also, small insects can literally walk on the water because of water's high surface tension. Water molecules also like to stick to other substances. This is called adhesion. The combination of adhesion and high surface tension means that water is good at climbing upward in narrow openings. As a little water adheres to soil, more water beads up with it, going a little bit higher, where it adheres to more soil, etc. In this manner, water can climb up through soil pores, cracks in rocks, and through roots and stems. The polar nature of water also helps it dissolve other polar substances. It's so good at dissolving things that we sometimes hear water referred to as the universal solvent. Indeed, you will never find pure water in nature. There is always other materials dissolved into it. Even as it rains down from the sky, it is dissolving into it substances that are found in the air. Water always carries a wide variety of dissolved substances, including nutrients, as well as tiny solid particles and bacteria in suspension. We noted that the polar nature of water results in liquid water molecules being held together by hydrogen bonds. When water evaporates from a liquid to a gas, it takes a significant amount of energy to break these hydrogen bonds. You can see here, in the liquid, the water molecules close together due to the hydrogen bonds, and when water evaporates to a gas, the molecules have broken those bonds. This energy that's used to break the bonds is stored as latent heat. Since energy is removed from the system, the remaining water is cooled. When water recondenses back to the liquid state, this energy is released. This storing of releasing of energy during evaporation and condensation leads to cooling and heating in the Earth's system. So because of the hydrogen bonds, water has a high heat of vaporization. It takes a lot of energy to get water to go from the liquid to the vapor state. We can see that in this diagram as well. Here's the total number of calories needed to go from ice to liquid and to go from a liquid to a vapor. Notice the high latent heat of vaporization. Again, this is energy that's stored as latent heat during evaporation, resulting in the cooling of the remaining liquid. So evaporation is a cooling process. That's very important to know. Your body uses this evaporative cooling process to cool you down too when you sweat. That's why you need to drink a lot of water when it's hot, so that your body can use that water to cool you through evaporation. Notably, all the energy that it takes to evaporate water is again stored as latent heat, and when the water recondenses, heat is released. So condensation is a warming process. Refrigerators and air conditioners use these processes. The last property we're going to discuss is specific heat. Water has a very high specific heat. We've already discussed this in some detail earlier in the course, in Chapter 4. A high specific heat means that it takes a great deal of energy to raise the temperature of water 1 degree. This fact helped explain why coastal areas tend to have more moderate temperature profiles than continental areas, and why the hottest and coldest places on Earth tend to be within the continental interiors, not coastal. Interestingly, substances with high specific heat, like water, can also be used to make homes more energy efficient. Using water tanks or thick stone floors, we refer to these materials as thermal mass in a home. They absorb the heat energy during the hot times of the day and release it at night, thus keeping a home cooler in the daytime and warmer at night, with no air conditioning or conventional heating. Pretty cool. But for now, just review the impact that this high specific heat of water has on keeping coastal areas more moderate in temperature, and thus the continental interiors are actually more extreme in temperature. All right, so we're finished with our introductory discussion on the properties of water. Can you, without your notes, list several important properties of water and note their importance for our study of physical geography?